All right, so let's continue. If you remember last week, we talked about some basic and kind of like easy issues for you, especially we talked about the mean, median, and mode, which you already know from high school knowledge, even from middle school knowledge, I believe. And however, on top of that, we try to do constructing some graphs also on top of it. And constructing graphs needs little bit experience actually. So if I suggest you that gather some kind of a data set and try to create your own graphical representation of the data set, okay? Because the more you practice on drawing graphs, the more you will do it, or the better you will do in the end. All right. So if you are not practicing with anything, then probably in the exam, definitely I will ask you to draw some kind of a graph. All right. So to do that graph properly and like in a nice way, or in a way that is easy to understand just by looking at it at once. So you will need some experience. Okay. Before any further ado, let's just go back to our last presentation slide. If you remember, we stopped here last week and there was like one single question left, and I said, okay, I'm just going to stop here last week. So this is a question, for example. Let's try to understand what it asks us. All right, it tells us, just a second. Yeah, it tells us the following data is related that in exercise 124. Okay, that's not important for us. Here, it gives the percentage of the families that are in the upper income level for the same individual schools in the same order as in exercise 121. These are not important for us again. What is important here is here. It is telling us the percentage of families that are in the upper income level. So, and it's talking about some schools or anything in schools or so as well. So that means we are looking at several schools in Aydin, for example. Okay, how many schools are here? There's like 4, and then 4 for 8. 8 times 4, 32. 2 missing. There's like 30 schools. So we are looking at 30 schools and the vicinity of those schools. What is the vicinity? Vicinity means civar in Turkish. All right, let me just write that as well. Just maybe you know this word, maybe you don't know it. Okay, vicinity. Vicinity means bir şeyden bahsediyorsanız, for example, in the vicinity, demek yani etrafında, civarında anlamına geliyor. All right. So let's just erase that. We don't need it. Okay. These are the percentage of the families that are in the upper income level. Yani yüksek gelir grubundaki ailelerin yüzdeleri. For example, in one of the school, the people who live around the school, okay, the 72% of those people are considered, well, we can call them rich in short, right? Up in the upper income level means they are rich. However, look at this school area. Probably this is like a poor side of the town, and only 8.5% of the people living in the vicinity are considered to be rich. So based on that, this is the data. Okay, the calculated sample mean. Very simple, right? Add them all up, divide by 30. Calculated sample median. Sample median is also easy. So you reorder these numbers from the smallest number, which is 8.5, to the largest number. I'm guessing 89.2, the largest number. Look at this school is probably in the rich side of the town, right? It's the other side of the railroad tracks generally. In the cities, well, not in maybe Turkey cities, but in the United States, most of the cities are divided by railroad tracks. And on one side of the railroad tracks is the poor side of the town. And the other side of the railroad tracks are the rich side of the town. Generally, something like that. There's this kind of distinction. Maybe not applicable, but still you can see some effects of that distinction that was done in the past. So you reorder them from the smallest to the largest percentage numbers, and then you take the median number. And since we have right now the 30 sample numbers, 30 samples, that means it's an even number. So what would be the mean? The mean would be the average of the 15th number and the 16th number after you reorder them from the smallest to the largest, okay? Because we have even number of samples. And the last one is construct a relative frequency histogram of the data. Constructing a relative frequency histogram. So, like I said, for the mean and median, it's easy. However, for the relative frequency histogram, that means they're asking us to draw almost like a bar graph looking stuff, right? That is histogram. Remember the difference between the bar graph and histograms. Histograms, the bars are touching each other. In the bar graphs, the bars are separated because they are categories, different categories. And there are no two categories that are side by side, actually. You can change the order of the categories, doesn't matter. However, in the histogram, you are ordering the bars based on their values. So the smallest value bar would be to the closest to the zero origin, and the largest value bar would be the farthest from the zero origin, okay, on the x-axis. So based on that relative frequency histogram, how do we approach this? First of all, let's look at the smallest number. The smallest number is 8.5. Let's find out that one. Okay. And then what else we have? We have the largest number. Okay, the largest number is here, 89.2. Okay, now let's think about it. This is the range, okay, of the data set, and all the other numbers are between these two values. Okay, good. And in the relative frequency histograms, or in any kind of representations, how many classes should we create? Okay, generally the good number, the suggestion is that try to make class numbers between 5 to 20. Okay, however, 20 is only when you have too many data numbers. Too many data, let's say, okay. Maybe like we have like thousands of data or hundreds of thousands of data, a lot of. So generally 20 is too much for us. 10, yeah, it might be also too much. So we are generally between 5 to 10 in this kind of normal size graphic, normal size data sets. All right, so let's try to find out if there is any logical way. Also, when you create the classes, they should be logical. See, we are talking about like tens, like 8.5, and 90s. So how about if I group them by tens, maybe like a 0 to 10, one class, 10 to 11, 10 to 20, another class, 20 to 430, another class, and all the way, I can go all the way 90, right? Here is 80 and 90, and there are other classes. How many classes I would have? 1, 9. So I would have 9 different classes or 9 different bars to represent this data set. Is 9 a good number? Yes, I would say it's a good number. And also it's also quite logical. Look at they are all like even numbers, like 10, 20, 30, 40. So the boundaries of the classes are logical numbers. All right. So for example, if I try to create 10 numbers or 10 classes here, then what would it be? Let's say I'm trying to make like even number of classes. Then it will be something like that. 0 to 9 is one class, and then 9 to 18 is another class. 18 to 27 is another class, right? And then what else? The 36 is another class. And all the way I would have to like 81 to 90 is my last class, and the other ones in between. Yes, in this case, I would have 10 categories to represent the data set, but my boundaries are not logical. Well, they are logical actually. They are like the multiplication of 9s, right? Like demek ki çarpım tablosu gibi 9'un katları oldu. Gördüğünüz gibi. This is also logical, okay? However, not easy to understand at once. Yani böyle bir grafiğe bakar bakmaz Yani güzel yapmış da hepsi eşit. Tamam da niye 9'un katları gitmiş? 10'un katları gitse, 5'in katları gitseydi daha iyi olmaz mı? Ya da or you can go like the 25 class range, maybe like 0 to 25 and 25 to 50, 50 to 75 and 75 to 100. This could be your graph as well. But however, in this case, you would have 4 classes, right? 1, 2, 3, 4 classes. And that is generally considered to be low to represent a data set. Instead of going by 25, I would go by 20 in this case, like 0 to 20, 20 to 40, 40 to 60, 60 to 80, and 80 to 90. That would be a little bit better representation compared to the 4 classes. All right. So depending on that, but the best one actually, I would go with this one. Okay, by 10s and 9 classes. And if you do all of that, this is the answer that you would find probably if you solve everything correctly. So here it is. the mean value, the average value will be 33.31%, the X bar, the X tilde, which is the median would be 26.35 if you do the rearrangement correctly. And for the histograms, here they are showing like the 10, 20, 40, 50s in middle numbers, by the way, in mid ranges. So in this case, how they did this graphical representation? By here. So that means they started from 5, okay, oh sorry, and here is 15. Keep it, sorry about that. Let's check it out here. And here, this means, oh sorry, I need to get the pen again. So here they took it 85, and here they took it 95. And here this area is 75. So they started going by, starting with 5, and also kept going 10 units at a time. This is also another representation. Why do you think they did this? Because they want to show in this horizontal axis the mid-range of the bars. And the mid-ranges are the even numbers, right? Between 85 and 95, the mid value would be 90 here. So they are showing 90, if you notice. And so they can show the even numbers down here. Okay, this is another way. This is another way. However, if you do it the way that I suggested in the previous slides, then the mid numbers would be, for example, here it would be like 35. And here it would be 45, here, this value, okay, instead of 30. Are they both okay? Yes, they are both okay. And anything like wrong between either graph? No, nothing is wrong between either graph. All right, both of them are correct, and both of them can be acceptable. All right, that's all for the leftover course from last week. All right, now I'm just gonna change our topic to probability. Okay, now we are starting a new topic now. Hopefully you learned about the data sets and stuff. All right, now let's talk about probability, guys. What is probability? In Turkish, olasılık. All right. So why are we learning probability in the statistics course? Because like in the beginning of the courses, most of the times, we cannot observe the entire data set. Okay, so we are doing generally statistics at that time. Conduct is like here it is actually what I want to show you. Most of the time we cannot observe the entire population. Okay, because population is so large and it takes too much time. It requires too much money to be spent to observe the entire population. So instead of that, we try to observe a sample selected randomly out of the population, and after observing the sample, we make inferences about the population. Okay, that means we are making some estimates of the population, and that is called statistics. And to do the statistics well, you should know the other part, well, which is the probability. Okay, because you should know that your sample is taken randomly out of the population. All right. Also remember that when you know about the entire population, you can guess the probability of selecting a sample data set. That is, you need the probability knowledge, the science area in that case. However, if all you know is the sample, then you will need statistics on your side to make estimates about the population. All right. So nothing in life is certain. Like as we know, for example, am I going to get coronavirus tomorrow? I don't know. Maybe it is possible. How possible? There are some numbers like those. Like every city is now colored with different colors in Turkey. Like Aydin, I believe, is orange now, and 2 weeks ago it was yellow. So that means like catching coronavirus in Aydin was had a lower probability 2 weeks ago than compared to today, because today the color is orange. That means the probabilities are increasing. Well, I should not say probability in that case, since it's a negative issue. Then we can say the risk is increasing, right? Probability also constitutes to be risk. And in everything we do, we gauge the chances of successful outcomes. Gauge means measure, okay, measure. And from business to medicine to the weather also, like the weather. For example, you look at the outside today and then you say, is it sunny or is it going to rain? So because depending on your answer, you're going to take your umbrella with you or not. So you look at the weather and you look at, okay, sun as outside, and you say, it's not probably going to rain today. So you leave your umbrella at home. But still, you're taking a risk here, right? It might be sunny now, but in the afternoon it might rain. Who can guarantee that? If you're just by looking, if you're looking just to the sun, you might make mistakes. However, if you listen to the weather forecast on the TV, because those people are using also scientific information, they are looking at the air currents, the movements of air, and movements of the, like the humid air, cold air, hot air, how they are interacting with each other. So they are giving you some percentages. Sometimes they say, in Aydin, tomorrow there is a 60% chance of rain, they say. What does that mean? 60% chance of rain. Is it going to rain or not? They don't say that. They say 60% chance of rain. So that means, yes, it might rain, and it is a little bit highly likely to rain than not rain. Okay. However, sometimes they say, in Aydin tomorrow, there is like a 95% chance of rain. That means definitely going to rain. But however, there is only a small bit of chance that it may not rain. Sometimes they do this kind of forecast. A probability provides a quantitative description of the chances or likelihoods associated with various outcomes. Outcomes means buna ne diyebiliriz? Olay, yani ortaya çıkan sonuç. Yeah, outcome, maybe sonuç would be better description. And it provides a bridge between descriptive and inferential statistics. So what is probability? Again, in previous lectures, we used graphs and numerical measures to describe data sets, which were usually samples. We measured how often using the relative frequency. For example, how often would we get a 6 after throwing a die, right? Mesela biz zarı attıktan sonra hangi sıklıkla 6 gelir düşündüğünüzde, this is called relative frequency, and then the answer would be 1/6, correct? Because frequency over the total number of outcomes. Zarda 6 tane yüz var, right? There are 6 sides of a die. Here is a die. There are 6 sides of a die, and one of them is only our expected outcome. For example, getting a 6. Okay, the relative frequency would be 1/6 in that case. Okay, and as the n gets larger, so that means as the n gets larger, what happens? Our question of how often, okay, our question of how often becomes relative frequency at that time. All right, guys, because when the n is getting larger, we are reaching to the entire population. Okay, think about it this way. So we are looking at the relative frequency, but at that time, now we are looking at in the population, the entire population. All right. So let's look at some of the basic experiments to understand the topic a little bit clearer. All right. An experiment is the process by which an observation or measurement is obtained. Okay. And now these are some of the definitions. An event, olay Türkçe, an event is an outcome of an experiment. Bir deneyin sonucudur diyor. Usually denoted by a capital letter. Generally, we use capital letter to describe an event. The basic element to which probability is applied. Events are basic elements to which probability is applied. And when an experiment is performed, a particular event either happens or it doesn't happen. For example, the experiment would be like today, the rain, okay? Is it gonna rain today? This is the experiment. When are we going to know this for sure? At the end of the day, okay? At the end of the day, if it rains, then it rained. At the end of the day, if it didn't rain, then it didn't rain. All right, this is the outcome in the end. An event that cannot be further decomposed is called a simple event. Okay? Daha küçük parçalara ayrılamayan bir olaya, yani o olayı daha küçük parçalara ayıramıyorsan bu olaya biz basit olay diyoruz. Okay? Basit olay. The set of all simple events of an experiment is called the sample space, and we denote it by capital S. Okay, sample space. So that means every single possible outcomes that are listed in the sample space. Correct? So now let's look at some of the examples. One of the experiments is easy, like flipping a coin. Here is a coin. Okay. What are the possible outcomes of if we flip a coin? One of them is H, capital H. That means observing a head. Değil mi? Tura gelmesi. Or the other event is tail. That means observing a tail. Okay. And there is also this condition as well, right? However, generally we neglect this. Burada bir de öteki olmaz. Üçüncü olması lazım değil mi? Para yatın dik gelirse ya da diğersin. Tabii. Onu genelde ihmal ediyoruz. However, these are the outcomes. Okay, these are the events at that time. And altogether, this is called the sample space, right? Observing a head and observing a tail. This is our sample space. When you flip a coin, there is no other chance. Değil mi? Bozuk parayı havaya attığımızda sadece iki olay olabilir. Bu iki olaydan başka bir şey olmaz. Yani işte ne bileyim kuşun bir havada parayı kapmazsa ya da ne bileyim para dik gelmezse ya da arkadaşın havada yakalamazsa gibi bu saçma olaylardan haricinde sadece iki ihtimal var. Yazı gelecek, tura gelecek. And the combination of both those two events is called the sample space. So there is no other option. Okay? Another one. Recording age of people, for example. İnsanların yaşını kaydediyoruz. And in this case, we can also attain some categories or some outcomes. Okay, we can create our own outcomes here if we want to. For example, we can call everybody as A if the person is 30 years old. Okay? Actually, in the beginning, how are we getting the numbers? We are getting, for example, what's your age? 45, right? 45. What's your age? 21. What is your age? 22. What is your age? 25. So you write everybody's ages. And after that, we can play on the data, okay? We can regroup the data. For example, we can call everybody who are 30 years of age, we call them A. Mesela niye? Belki 30 yaşındaki insanlarla özellikle bir onlara özel bir sorunuz var yani. Hani 30 yaşına geldiniz. Hani ne öğrendiniz gibi bir şey soracaksınız. O zaman diyorsunuz ki A olan kişilere şu soruyu soracağız. Mesela değil mi? Kim onlar? 30 yaşında olanlar. Bunu niye A dedik bunları? Demeseydik de anlamıyor muyduk? Şöyle ya direkt 30 yaşındakilere şunu soracağız desek olmuyor muydu? O da oluyordu. Ama öyle olunca herhangi bir tanımlama yapmamış oluyorsunuz. Böyle bunu tanımlayabiliyor. Yani bir kodlama sistemi geçiriyorsunuz. Okay, this is some kind of like a coding system. So everybody who are 30 years of age, we call them A. And also, look at person is older than 65, we call them B. Yeah, see, this is now important in the coronavirus cases because now the government is telling people like maybe like 6 months ago, they were saying that people over 65 years of age, they should not go outside, right? They were giving these kind of rulings, for example. So in that case, instead of saying like people who are older than 65 doing this, well, you can say also this, like categorize everybody and say B'ler çıkmasın. Mesela the B's should be at home. Who are the B's? The B's are everybody who are older than 65 years of age. Okay, this is called like a categorization on the data set later on. Another one experiment is tossing a die, for example, observing an odd number. We can call them A. However, after you toss a die, what are the sample space? Sample space is 1, 2, 3, 4, 5, and 6, right? There are only 6 outcomes after tossing a die. Then we can play with these 6 outcomes. For example, all the odd numbers, we can call them A. Mesela bütün tek rakamlara A diyebiliriz. 1, 3 ve 5'i alıp bu üçüne A diyoruz. Kalanlar ne? Başka bir kategorizasyon. For example, observe a number greater than 2, let's call them B. Yani 2'den büyük rakamlara B diyelim. Yani which are those ones? 3, 4, 5, and 6. These 4 of them, we call them B, for example. Okay? Different kind of groupings. You can do that as many groupings as you need necessary. Let's look at this question now. And hopefully you can read it. The letters are small, but I hope that you guys are able to read it. I will read it for you, by the way. An electrical engineer has on hand 2 boxes of resistors. Has on hand ne demek ya? Elinde var diyor. Ne varmış elinde? 2 boxes of resistors. Resistor direnç. Yani şu küçük böyle fasulye gibi, mercimek gibi şeyler devrelerde olur ya, dirençler. 2 kutu direnç varmış elektrik mühendisinin elinde. Güzel. With 4 resistors in each box. 2 kutu. Ama her kutuda da 4 tane direnç var. Alright. The resistors in the first box are labeled 10 ohms. But in fact, their resistances are 9, 10, 11 and 12 ohms. Kutuların birinin üstünde 10 ohm yazıyormuş. Bu direncin birimi. 10 ohmluk dirençler varmış. Ama aslında gerçekte onlar hepsi 10 değilmiş. Onların gerçekte rakamları 9, 10, 11 ve 12 şeklinde. Alright. However, they were put on the same box because their resistance values are close to 10. The resistors in the second box are labeled 20 ohms. However, they are in fact their resistances are 18, 19, 20 and 21 ohms. Bunlar da işte yüksek gruplu, düşük gruplar. Now the engineer chooses one resistor from each box. Her kutudan birer tane seçecekmiş. And determines the resistance of each. Her birinin de direnç miktarını da ölçecek. O cihazına, makineye koyacak. Ne kadar direnç var bunu ölçecek makinede. Okay. Let capital A be the event that the first resistor has a resistance greater than 10. Ne diyor? A şu olsun diyor. A olayı. Neymiş? 2 tane birden seçiyor ya. Birinci kutudan gelen direnç 10'dan büyük olmalı diyor. Yani ne olabilir? Sadece 11 ve 12 olabilir. So it could be only 11 and 12 because it says greater than 10. Right? 10 is out of question here because it says greater than 10. Let B be the event that the second resistor has a resistance less than 19. Less than 19. Less than 19 is only 18. There is only 18 here. So in B, let C be the event that the sum of the resistances is equal to 28. Okay, sum of them is equal to 28. Find the sample space for this experiment and specify the subsets corresponding to the events A, B, and C. All right, let's write the sample space. Sample space is easy. Okay, we will take one from here, one from here. What are the possible outcomes? Sample space means every single outcome that can be observed. Let's continue with the first one. From the first box, I can get a 9, right? Yes. And from the second box, there are 4 different options. I can get a 9, and 9 with 18, 9 with 19, 9 with 20, and then 9 with 21. So write each of them. 918, 919, 920, and 921. And repeat everything for the other ones, like 1018, 1019, 1020, 1021, 1118, 1119, 1120, 1121, and for the 12. 1218, 1219, 1220, 1221, and close the parentheses. So that means these are all the possible outcomes if you select one resistor from each box. Now, let's write the events A, B, and C. Event A, what was it? It was event A, the first resistor has a resistance greater than 10. 10 means here, this 11s and all the 12s, right here, 11s and 4 12s, all of them. This is called A. The B would be less than 19. Less than 19 is only, there is this one. So 18 with all of those 4 of them. Here, 918, 1018, 1118, 1218. So we are selecting these values out of the sample space. And the C would be, the sum of them would be 28. 9'a kaç eklersek 28 olur? Okay, 9 plus what makes 28? 19, right? Yes. And then 10'a kaç eklersek 18. 10 plus 18 would be 28 again. 11 plus, well, it would be 17, but there is no 17. So 11 is out, 12 is out. So there are only two couples here, 919 and 1018, because their sums are equal to 28. So these are the events. Bu şekilde yazdık. Niye yazdık? Çünkü bunlarla ilgili bir işimiz var sonra. Bunları kullanacağız. Bu şuna benziyor. Hani bir ödev yazarken de bazen kısaltma kullanırsınız ya, hani uzun kelimeleri atıyorum. Türkiye Büyük Millet Meclisi. Ama siz diyelim ki makaleye bir şey yazıyor, ödev yazıyorsunuz. Ödevin ilk başta yazdınız. Türkiye Büyük Millet Meclisi'nde, sonra parantez aç, TBMM, kapat parantez, devam et cümleni. Sonra ödev bitti. Bir baktın sadece bir kere Türkiye Büyük Millet Meclisi yazdık. O zaman niye ben onu parantezde gösterdim ki? Parantezde göstermemin amacı bir daha kullanırsam TBMM yazayım diye gösteriyorum mesela. Başka hiç yazmadıysan TBMM bir daha, o zaman o parantezi sil. Gerek yok öyle bir tanımlamaya. Sadece açık açık adını yaz. Here, this is the reason same actually. Bunları niye gösteriyoruz böyle? Çünkü ben bu A ile, B ile, C ile bir işim var. Onları her seferinde tekrar uzun uzadıya yazmamak için buna B diyorum. Sonra B hakkında atıp tutuyorum mesela. İşte B'lerde şöyle, B'ler böyle, B böyleydi, A şöyleydi deyip bunların üzerine artık yorum yapıyorsunuz daha ileri. O yüzden bunları hazırlıyoruz. Okay. Now let's look at the tree diagram. This is another way to represent the probability. An experiment consists of flipping a coin and then flipping it a second time if a head occurs. However, if a tail occurs on the first flip, then a die is tossed once. Anladık mı soruyu? Did you understand the question? Here, look at it. Experiment consisting of flipping a coin, and depending on the result of the coin flip, You decide what to do next in the second attempt. So in the first attempt, flip the coin. Okay. If the head occurs, flip it one more time. Okay, second time. However, if tail occurs in the first flip, then toss a die. Türkçe'ye anlatalım. Elimizde bozuk para var. Bozuk parayı, deney seti bu. Bir kere bozuk parayı atıyorsun. Ne geldi? Diyor ki, tura gelirse parayı bir daha at. Yazı gelirse o zaman bir tane zar at. Gördüğünüz gibi farklı seçenekler gidiyor. Birinci deneyin sonucuna göre ikinci deneyi değiştirebiliyorsunuz. So here it is. The first outcome. The first event would be the flipping a coin. If a head occurs, what are we going to do in the second? If tail occurs, what are we going to do in the second one? Second outcome. Remember, if a head occurs here, if a head occurs, flip it a second time. Demek ki in second time, flip the coin again. That would mean that after the head, I can get another head or another tail. Correct? Let me just open that for you. If a head occurs, I get it one more time. Head or tail, the other options. However, if a tail occurs, then I toss a die. And the outcomes of a die are 6 numbers. Zar atınca 6 ihtimal var. 1, 2, 3, 4, 5, 6. Alright? And sample point, what are the total outcomes? Total outcomes would be here, head and head. Birinci de tura geldi, ikinci de tura geldi. Here, head, head. The second outcome would be head and tail. Head and tail. Here, HT. Third one is tail 1. Yazı geldi, sonra 1 geldi. Yazı geldi, 2 geldi. Yazı geldi, 6 geldi. Tail 6. Okay. These are the sample space after conducting these two experiments. Okay. Bu iki deneyi arka arkaya yaparsanız eğer, yani bütün ihtimalleri düşündüğünüzde bu sonuçları elde edersiniz. No, 2, 6, 8. Herhangi bir 9. ihtimal var mı? Yazmadığımız. Yok. Bütün ihtimaller burada. This is called tree diagram. Ağaç diyagramı. Bu ağacın dalları gibi olun. However, we cannot show everything by the tree diagram. Okay, because sometimes you have huge numbers of data, huge, big numbers of data. So that means if you start writing every single outcome, you don't have enough time, technique. You don't have that much time in your life, basically. Okay, sample spaces with a large or infinite number of sample points are best described by a statement or rule method. Okay, bazen sample space'i böyle baş edilebilir boyuttaysa yazarız hepsini. İşte bu olabilir, bu olabilir. Mesela sınavdan kaç alabilirsin? En fazla 100 alırsın, en düşük 0 alırsın. Bütün alabileceğin ihtimalleri yazabilir misin? Yazarız. 0'dan 100'e kadar rakamları yazarsın. Okay, those are all the possible outcomes that you can get after the exam, right? Either 0 or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and all the way to 100. Any value you can get. However, sometimes you have infinite numbers of outcomes. Yazmaya kalkarsan yani sonsuz sayıda sonuç çıkabilir ortaya. So in that case, instead of writing every single outcome, we write a statement. Bir tanım yaparız bazen sadece ya da bir kural koyarız. Okay? For example, sample space is X. And what is that X? We put a vertical line here and we read it such that X is a city with a population over 1 million, close to parentheses. So this is our sample space. See, I wrote every single city with the population over 1 million. Instead of writing the names of every single city in the world here. Right? Start with Istanbul, Tokyo, Mexico City, New York, what else? I don't know, like Miami maybe is another one, Munich, Moscow, okay? All the big cities, instead of writing them, don't write the names, just make a description. And how are we going to read this description? Here, which reads as S is the set of all x's such that X is a city with a population over 1 million. Vertical bar red such that. All right. Here is another one. Sample space is X and Y couples such that X squared plus Y squared is less than or equal to 4. Okay. Burada başka bir sample space. Mesela sample space nedir? X ile Y'den oluşur ki onların karelerinin toplamı 4'e eşit veya 4'ten düşük olabilir. Olan bütün X ve Y ihtimalleri bizim sample space'imizde. Alright? Alright. An event is a subset of a sample space. Alright? An event is a subset of a sample space. Yani sample space'in içindeki her ihtimalden birisi. For example, if your sample space is this, X such that X is a city with a population over 1 million, for example, Izmir would be an event here, right? Because Izmir is a big city with a population over 1 million. However, Aydin would not be an event because Aydin's population is not over 1 million, all right? This is called an event and a member of the sample space, okay? Or also you can combine some of the events to make another event or like a combined event, okay? Combined event will be better description probably. And we have another description called complement of an event A. The complement of an event A with respect to sample space S is the subset of all elements of S that are not in A. We denote the complement of A by the symbol A prime. Okay? That means yani A prime demek A'nın dışında kalan her şey anlamına geliyor. A'nın komplementi. Okay? A'nın tamlayanı. Alright? A prime. That means every single events in the sample space that are not in A. A olmayan her şey. Intersection of two events. If you notice, this is going to be a simple topic now. Intersection of two events, A and B, denoted by the symbol A intersect B, is the event containing all elements that are common to A and B. Bu bildiğiniz A kesişim B. Okay? That are common to A and B. Okay. And then if the two events A and B are mutually exclusive, that means they are completely separated from each other or disjoint, birleşik değil. And if A intersect B is empty set, that is, if A and B have no elements in common, okay, that means they are also mutually exclusive because in the intersect there is nothing, yani common olan hiçbir şeyleri yok. All right, and also when there is intersection, there is also union. The union of A and B, the two events A and B, denoted by the symbol of A union B, is the event containing all the elements that belong to A or B or both. Okay, bu da A birleşim B. Bildiğiniz ortaokul bilgisi. Now, let's look at this experiment. Our experiment is tossing a die. What are the possible outcomes? 1, 2, 3, 4, 5, 6, right? These 6 numbers are the possible outcomes. Okay, let's create more events. For example, A would be observing an odd number, like odd number 1, 3, and 5. Okay. B is observe a number greater than 2. That means 3, 4, 5, 6. These 4 outcomes. C is observe a 6. 6 gelmesi durumuna C diyelim. 3 gelmesi durumuna D diyelim. Özellikle mesela. Alright? And let's try to list them. Alright? For example, our sample space after tossing a die is 1, 2, 3, 4, 5, 6. Perfect. And what is the event A? Observe an odd number. Event A is 1, 3, and 5. Event B is number greater than 2. That means all the numbers in the sample space that are greater than 2. That means here 3, 4, 5, 6. Here it is 3, 4, 5, 6. Event C, well, it's written 6. Event D is 3. All right, these are the other C and D events. Okay. All right. Now let's look at some questions. A union B. What is A union B? That means every single event that are listed in A or B or both. So A union B would be 1, 3, okay, 4, 5, and 6. What about 2? 2 is out of the question here. A union B would be, here it is, 1, 3, 4, 5, 6. A intersect B means the values that are common in A and B. Which ones are common? The 3's are common and 5's are common in A and B. So A intersect B would be 3 and 5. B prime, okay, remember B prime. B prime would be the complement of the B. Yani complement of B. In what sense? If you look at from the sample space. Okay. What are left in sample space that are not listed in B? 3, 4, 5, 6. Only 1 and 2 left. So B prime would be 1 and 2. All right. That means B'nin dışında kalanlar anlamına geliyor. And C intersect D. And if there are any common values here, there is no common. So that means it's an empty set. Okay. There is nothing here. So by writing this way, we can also show this kind of relationship by showing Venn diagrams, which is like a middle school knowledge for you. In a Venn diagram, we let the sample space be a rectangle. This rectangle generally, outside rectangle, is the entire sample space. Okay, and then represent the events by circles drawn inside the rectangle. Eventleri de sample space içinde yuvarlaklarla gösteririz genelde. All right. For example, here in Venn diagram illustrating various events like A union B means A union B, all of the values that are covered in A and B. In B, A intersect B. Here, A intersect B is this middle area. Here, B intersect A complement or A prime. B intersect A prime. What is A prime? A prime is anything outside A. This is A. Anything outside A. So B intersect outside A is this part. This is called B intersect A prime. Okay? Not here, only this part. All right? In this case, for example, A and B are mutually exclusive, that A is different, B is different. There's nothing in common between them. All right? These are some other complex representation of the events also. Now, okay. What about showing this, our sample in the Venn diagram? Can you do that? Showing our example, like our sample space is 1, 2, 3, 4, 5, 6, and you will draw A in between showing 1, 3, and 5, and you will draw another circle showing 3, 4, 5, 6, and make sure 3's and 5's are in the common area for A and B, okay? And C for the 6 and D for the 3. If you try to show all of them in a one Venn diagram, this is what you would observe, something like that. Sample space outside, all the values 1, 2, 3, 4, 5, 6, written only once. And A would be 1, 3, 5. Here, 1, 3, and 5 is covered by A. And 3, 4, 5, 6 is covered by B. And also remember, 3 and 5s are in the intersection area, 3 and 5s. And 3 is also single, is called a T. 6 is also called C. This is the Venn diagram representation of our example. Okay. Now look at this question. Okay, for this question, what I will tell you is, this is your homework for this week. Okay. I will upload this homework question to you after the course. All right, this is your homework for this week. Consider the sample space. Consider the sample space called copper, sodium, nitrogen, potassium, uranium, oxygen, and zinc. And the events are: A is copper, sodium, zinc. B is sodium, nitrogen, potassium, and C is oxygen. Now, list the elements of the sets corresponding to the following events. What is A prime? Listed. What is A union C? Listed. What is A intersect B prime union C prime? List all of them. What is B prime intersect C prime? So based on B is here, C is here, and this is the sample space. Find the B prime, find the C prime, and see if there's an intersection between them. List all of them. And A intersect B intersect C. List all of them. And look at the last one. A prime union B prime intersect A prime intersect C. Okay. Also look at it. Be careful about the parentheses. Do the functions in the parentheses first, and then do the last in later. Okay. This is your small homework for this week. All right. I will upload it after the course, by the way. Now, let's continue. The counting rules. Okay. Sample space of throwing 3 dice has 216 entries. Okay, let's start with the first one now. If we throw sample a 1 die, how many options are available? 6 options, right? Yes. If I throw 2 dice, 2 tane zar atarsam kaç seçeneğim olur? Kaç olur? Kaç tane seçenek elde edebiliriz sample space'i sonunda? Düşünürseniz ilk zarda 6 ihtimal var, ikinci zarda 6 ihtimal var. Yaklaşık 36 tane farklı ihtimalimiz var, değil mi? Böyle durumda. Yes. And also, if you throw the dice 3 dice, you have 216 different outcomes, entries. Sample space of throwing 4 dice has 1296 entries. Yani 4 zar atmanın sonucunda 1296 farklı sonuç elde edebilirsiniz. So at some point, okay, if you are keeping rolling some die in your life, at some point we have to stop listing all of them, because listing this many entries, 1296 tane meydana gelecek muhtemel sonucu alt alta yazmak yerine bizim bunu daha kolay gösterebilmemiz gerekiyor artık. Yani bir yere kadar yazıyoruz. Okay, and we have to start thinking how to write this in a shorter way. So we need some counting rules for that. One of the counting rules is multiplication rule, or we can call it MN rule. Okay, if an experiment is performed in 2 stages, okay, if an experiment is performed in 2 stages, 2 basamaklı bir deneyiniz varsa, with m ways to accomplish the first stage and n ways to accomplish the second stage, then there are m times n ways to accomplish the experiment. Bu gayet basit bir yöntem. Eğer birinci işlem basamağını m şeklinde ya da m farklı yönde yapabiliyorsanız, ikinci işlem basamağını da n farklı şekilde yapabiliyorsanız, toplamda kaç farklı şekilde yaparsanız m çarpı n, değil mi? Mn ways. So this is called multiplication rules. This rule is easily extended to k stages. Sadece 2 stage değil, we can extend it to k stages with the number of ways equal to n1 for the first stage times n2 times n3 times n all the others and times all the way to nk. Yani k stage'e kadar yapabiliyorsanız bütün işlemleri çarpacağız. Gayet basit çarpım formülü. Alright. For example, toss 2 coins. The total number of simple event is how much? 4, right? Because tossing 1 coin has 2 outcomes. Tossing other coin has another 2 outcomes. Birinci deneme bozuk parayı attığımızda yazı ya da tura gelebilir. 2 ihtimal. İkinciye attığımızda yine yazı ya da tura gelebilir. İki ihtimal. Dolayısıyla overall we have 4 different outcomes. Let's list them. Okay. In the first one could be, sorry about that. First one could be a head, and then second one would be tail. First one could be head, second one could be head. First one could be tail, second one could be tail, and first one could be tail, second one could be head. Okay, these are 4 different outcomes. Here it is, 4. We knew that already. Now, if you throw it 3 times, or if you toss 3 coins, the total number of simple events is 2 times 2 times 2, which is 8. If you toss 2 dice, bakın bozukları artık zar atıyoruz. 2 tane zar attıysak 6 times 6, which is 36. If you toss 3 dice, 6 times 6 times 6, which is called 216 different outcomes are possible if you toss 3 dice. Okay, now let's look at this small example for our core class. A certain make of automobile, make bu arada araba markası anlamına geliyor. Yani yapımcısı arabanın. Mesela ne olabilir? Atıyorum Türkiye'den olsun. Türkiye'de araba yok. O zaman yurt dışına çıkalım. Ne var? Aklıma ilk gelen Renault var mesela, değil mi? Fiat var, Mercedes var, BMW, right? These are different makes of automobiles. So a certain make of automobile is available in any of 3 colors. Bir tane araba sadece 3 tane renk yapılıyormuş. Başka renk yapmıyorlar. Düşünün artık havaya. Herhalde Lamborghini olsa gerek. And those colors are red, blue and green. Başka araba rengi yapmıyor. Mesela beyaz araba istiyorum diyorsun. Biz beyaz yapmıyoruz diyor. Bizden alıyorsun kırmızıyı, sanayide gidip beyaza boyatıyorsun. Herhalde bu yöntem bu. Red, blue or green. And it comes with either a large or small engine. Okay. Ya büyük motorlu ya da küçük motorlu geliyormuş. Alright. In how many ways can a buyer choose car? Very simple. How many ways can a buyer choose car? What are the options? 3 colors and 2 engine options, which is simple, right? 3 colors here, red, blue, and green. Engine sizes, large engine, small engine. So you can get a red car with a large engine. You can get a red car with a small engine. Same thing, blue car, large engine, blue car, small engine. Green, large, green, small. So there are 6 different possible purchases that you can make from this make of automobile. Okay, very simple. Okay, now let's look at another one. When ordering a certain type of computer, there are 3 choices of hard drives. Okay, 3 choices of hard drives. 4 choices for the amount of memory, 2 choices of video cards, and 3 choices of monitors. In how many ways can a computer be ordered? Kaç farklı şekilde bu bilgisayarı sipariş verebilirsiniz? Very simple again. 3 times 4 times 2 times 3. Okay, that is, so in 72 different ways you can order this computer. Okay, you have 72 different ways of ordering different computers. Now we are entering the probability a little bit more. Of course, when we say probability, we cannot explain a probability course without talking about the permutation, correct? Now, a permutation is an arrangement of all or part of a set of objects. Okay, permutation is an arrangement of all or part of a set of objects. The number of permutations of n objects is n factorial. This sign here is used, the exclamation mark is read as factorial. You probably knew this from high school mathematics knowledge, where n factorial means n factorial is equal to n times n minus 1 times n minus 2 times n minus 3 times n minus 4 times all the way to like, eventually you will end up like 2, 1, and 0 also. However, 0 factorial, we call it 1. Okay? This is the multiplication for the factorial. What does that mean, factorial? For example, let's do that with a simple example, which you probably know it by heart, but I'm just going to make a small example. So what is 4 factorial means is 4 times, because we start with 4, times 4 minus 1, that is 3, times 4 minus 2, that is 2, times 4 minus 3, which is 0, times 4 minus 4, but we don't write that 0. If you write that 0, it is unnecessary. So this is the answer of 4 factorial. 4 times 3 times 2. Well, 1 is also here useless because it's not going to change anything in the multiplication. All right? The number of ways you can arrange n distinct objects, taking them r at a time, is described. Here it is. Permutation of n things taking r at a time. Okay? Permutation of n things. Let me get that laser. Permutation of n things taking r at a time. The formula of that would be n factorial divided by n minus r factorial. Okay, again, hopefully a high school knowledge for you guys. But we need to remind you again for the probability purpose. All right, now let's look at this example and how can we solve this example. In 1 year, 3 awards, okay, and those awards will be research, teaching, and service awards. 3 awards will be given to a class of 25 graduate students in a statistics department. Yani tam yerinde bir ödül veriliyor. İstatistik bölümündeki lisansüstü öğrencilere, ki 25 tane lisansüstü öğrencisi varmış ve her yıl bu 25 lisansüstü öğrencinin 3 tanesine birer tane ödül veriyorlarmış. Mesela yılın en iyi araştırma yapan lisansüstü öğrencisi ödülü. Mesela kime gidiyor? İşte o çocuğa gidiyor. O çocuk çok iyi araştırma yapıyor mesela. Yılın en iyi ders anlatan lisansüstü öğrencisi. Çünkü niye? Laboratuvar derslerine girerler. Amerika'da lisansüstü öğrenciler. Lisans öğrencilerinin laboratuvar derslerine girip orada konu anlatımı yaparlar bazen. Örnek çözdürürler mesela. Deneme örnekleri. Ama en iyi 25 öğrencinin en iyi hangisi yapıyor bir yıl boyunca? Ona ödül veriliyor. Çok iyi anlatıyorsun sen konuyu diye. And Service Awards. Bu da işte yani ne araştırma yapıyor, ne bir şey öğretebiliyor ama 3. en iyi öğrenciye de hadi bir şey ödülü verelim demiş ama servis ödülü verelim demişler mesela. Mansiyon gibi düşünebilirsiniz belki. Ama geri kalan 22 öğrenci bir şey alamayacak. Sadece 3 öğrenciye ödül verilecek. Okay? In 1 year, only 3 awards are given to a class of 25 graduate students. Ve bu öğrenciler de istatistik okuyorlar. Düşünün bunların kafalarında nasıl hesaplar dönüyor şimdi. Hangi üçümüz alacak? Acaba kimin alma ihtimali daha yüksek? Hepsi istatistik öğrencisi. If each student can receive at most 1 award. Also there is a rule. So let's say there is this crazy great guy. Okay, he does everything perfectly. He is the best researcher. He is teaching the best, and he is also doing service to the community. All right. So that means he's gonna get all 3 awards, but they don't do that. They give 1 student only 1 award. So in that case, how many possible selections are there? Okay. How do you think we will solve the question? This looks like a permutation question to us. Okay. Why? Because first of all, the awards are different. Yani ödüller farklı. Şu ödül olsaydı 25 öğrenciye research, teaching ve servis alanı ödül vereceğiz ama hepsine birer bardak vereceğiz mesela. Sen research ödülü mü aldın? Al sana bardak. Teaching ödülü, al sana da bardak. Servis ödülü, al sana da bardak. Yani aldığı ödül fark etmiyorsa, sonuçta bardak alıyorsa hepsi, then this is not a permutation. However, here they separated the awards as research, teaching and service. Demek ki 3 farklı ödül var. Ödüller farklıysa, then in this case, this is a permutation question or a solution. since the awards are distinguishable. Distinguishable means they can be separated from each other, right? They are different. Research is different, teaching is different, service is different award. Then it is a permutation problem. The total number of sample point is, here, this is the how we solve the question, is permutation of 12 by taking 3. All right, 3 at a time. Permutation of 25 by 3. And this answer would be, based on the formula, is 25 factorial divided by 25 minus 3 factorial. Here it is. 25 times 24 times 23 times 22 factorial. Let's not write all of them. Divided by 22 factorial. And at the end, these 22 factorials cancel each other out. And we have only 25 times 24 times 23. Answer would be 13,800 different possible selections are available to give these 3 awards to the 25 students. Ya 13.800 tane ihtimal var. Ama biliyorsunuz ki bunlardan sadece birisi olacak. Ve bazen o da bellidir zaten kimin alacağı. Alright. Okay. The number of distinct permutations of n things of which n1 are of one kind, n2 of a second kind, and nk of a kth kind is written in this formula. N factorial divided by n1 factorial, n2 factorial, and nk factorial. So let's try to see a question and how we are going to apply this formula. All right. In a college football training season. Şimdi burada ne yapıyoruz? Tabii Amerika'dan bizim kitabımız, o yüzden when we say football, always remember this is American football. All right, not like a regular, like British football. Yani bizim bildiğimiz futbol değil bu. Bu topu elinizle alıp koştuğunuz ayak topu. Yani neresi ayak topuysa o da belli değil. This is college football. Üniversiteler, college demek üniversite. Üniversite futbol takımları arasındaki yarışmalar. Bu eğitim sezonunda ve training session diyor. The defensive coordinator needs to have 10 players standing in a row. Okay, let me first of all talk about a little bit from this American football, as much as I know. I'm not an expert, by the way. First of all, in normal British football, there are 11 players, right? One of them is the goalkeeper or the goalie, and there are 10 other players. Okay, goalie can use hands, and others cannot use their hands. They will use their foot to play with the ball. And that's all. Like you have 11 players, and other team has also 11 players. So you are playing on the game. However, in the American football, a team has 2 teams. Bir takımın 2 takımı var. Yani normal bizim bildiğimiz futbolda her takımın bir takımı var. Bir de yedekler var. Ama Amerikan futbolunda her takımın 2 takımı var. Bir de onların da yedekleri var. Neden 2 takım? Sebebi şu. Top kimdeyse hücum eden taraf o. Ama top rakipteyse bizim defans yapmamız lazım. O yüzden 2 takım var. Mesela top bizdeyse biz, yani her takımın bir hücum takımı var, bir defans takımı var. Yani topu kaybettik rakibe diyelim. Biz hemen o zaman defans takımını sahaya sürüyoruz. Neden? Onu da anlatayım. Hücum takımının görevi topu alıp karşı kaleye götürmek. Tabii topu alıp karşı kaleye götürmek için bir tane topu çok iyi fırlatan, böyle artık takım kaptanı, bütün 2 takımın da kaptanı diyebiliriz ona. Bir tane böyle iri yarı 1.92 metre boyunda kaslı, topu fırlattığı zaman bir uçtan bir uca atabilen bir oyuncuya ihtiyacınız var. Buna quarterback deniyor. Bu artık takımın yıldızı. Bu hani en yıldızı yani. Bundan yıldız yok. Öyle bir çocuğa ihtiyacınız var. Bir de o topu attığı zaman o topu böyle bir koşuda ileriye gidip o topu yakalayabilecek şimşek gibi hızlı koşuculara ihtiyacınız var ki ileriye koşup o topu yakalasınlar. Ve yakaladıktan sonra da rakip defansa yakalanmadan da topu böyle atlayıp zıplayıp akrobatik hareketlerle topu düşürmeden öbür kaleye götürebilsinler diye daha ufak tefek, hızlı, zayıf, atletik çocuklara ihtiyacınız var. Ama defans takımındaysanız da sizi rakip gelen o koşan hani hızlı şekilde bu tazı gibi koşan elemanları böyle yakalayıp indirip kemiğini kırabilecek kadar güçlü, yapılı ve atletik defans oyuncularına ihtiyacınız var. O yüzden takımların amacı farklı. So if you have the ball, you put your like attacking team on the field. If you lose the ball, you put your defense team on the field. So defans oyuncularınız genelde de böyle iri yarı, vurdu mu indiren cinsten. Hücum takımı daha böyle sinek gibi, koştu mu yakalayamayacağınız tipten oyunculardan oluşuyor. So that means you have now in here we are talking about a defensive coordinator. Bir tane defans koçu var, bir de hücum koçu var tabii. Okay? So defensive coordinator needs to have 10 players standing in a row. Yani 10 tane oyuncuyu böyle defansta, hani oyun başlayınca iki takım böyle karşı karşıya eğiliyorlar. İşte son rakamlar söylüyorlar rastgele. 3, 5, 8 deyip top atıyorlar. Burada defans oyuncu yan yana duracaklar ki karşıdan basınç geldiği zaman onlara karşı koyacaklar. However, in the college football there are rules. Herkes ister ki 10 tane defans oyuncusu işte üniversite 4. sınıf öğrencileri olsunlar. Niye? Onlar yaşları daha büyük. 4 yıl boyunca üniversitede futbol oynamışlar. Daha tecrübeli. Ama kurallar öyle işlemiyor. There are rules. Out of those 10 players, one of them has to be a freshman. Freshman means üniversite 1. sınıf öğrencisi. 2 of them should be sophomores. Sophomore means 2. sınıf öğrencisi. 4 of them should be junior, 3. sınıf öğrencisi. And only 3 of them could be senior. That means 4. sınıf öğrencisi. Alright? So these are the also years for the university. So, for example, you are now, I'm guessing most of you guys are sophomores because you are taking, this is the second year course, the statistics, FE 200, right? This is the code of the course. So most of you guys are sophomores, you are second year students. Okay, our defensive coordinator needs this 10 players. However, their school years are different. Now the question here, how many different ways can they be arranged in a row if only their class level will be distinguished? Sadece sınıflarına bakaraktan düşünürsek ayırt edilebilir olarak, mesela 2 tane 2. sınıf öğrencisi var ya, bunların kim olduğu değil de 2'ye gidip gitmedikleri önemli. Mesela 2'ye giden Ali ile Ahmet var. Ali mi Ahmet mi değil de sadece 2'ye mi gidiyor, 2'ye gitmiyor mu? O farkı ayırdı bakarsak diyor. Kaç farklı şekilde dizebiliriz bu öğrencileri? 10 kişiyi yan yana dizeceğiz. Bu kadar basit. So this is the formula guys. 10 factorial because we have only 10 players divided by the class numbers. Like for example, there is only one freshman, 1 factorial. 2 sophomores means 2 factorial. We have 4 third grade students, like 4 factorial, and 3 seniors, 3 factorial. Okay, this is the formula. And at the end, you have 12,600 different ways that you can arrange these 10 defensive students on the team as a defense team. All right? What's the time? All right, let's continue a little bit more. Often, we are concerned with the number of ways of partitioning a set of n objects into R subsets called cells. Okay, sometimes we do that also. We have like n objects and we want to group them or partition them in R different subsets. The order of the elements within a cell is of no importance here. When the order is not important, then this is a permutation again. When the order is important, then it becomes a combination. We're going to talk about that as well. The number of ways of partitioning a set of n objects into R cells with n1 elements in the first cell, n2 elements in the second cell, and so forth is written with this formula. Okay, n factorial divided by n1 factorial, n2 factorial, and nr factorial. Almost like this formula, if you remember. So the same kind of approach. See, however, we are doing different things, but look at the formula. Formula looks similar, like n factorial divided by n1 factorial, n2 factorial. Here is the same. n factorial divided by n1 factorial, n2 factorial, and also, okay, where n plus n, like n1, n2, and nr equals to total number of n also. Okay, this should be the rule. Bu her gruptaki n sayılarının toplamı da toplam n'e eşit olmak zorunda. All right. So this is a small question again. In how many ways can 7 graduate students be assigned to 1 triple and 2 double hotel rooms during a conference? For example, bir konferansa gidiyoruz, 7 öğrenci. Tamam mı? 7 öğrenci konferansa gidiyoruz. Ama pahalı olmasın diye de odaları ortak tutalım diyoruz. Çok mantıklı. Biz de öyle yaptık zamanında. Ama 7 kişiyiz. Kaç oda tutmamız lazım? Şu şekilde tutmuşuz. Bir tane 3 kişilik oda tutmuşuz. Triple. 2 tane de 2'şer kişilik oda tutmuş. Toplam 3 oda tutmuşuz. Okay. We have 3 rooms and we have 7 students. So in this case, in how many different ways we can accommodate these 7 students in the hotel rooms? The answer would be very simple again, right? 7 factorial divided by divided by 3 factorial, because the room can hold 3 students, times 2 factorial times 2 factorial, because we have 2 double hotel rooms. Okay, the answer would be, let me just write it again here so that you would know, 7 factorial divided by 2 factorial times 3 factorial times 2 factorial times 2 factorial. That would be the answer to find out how many different ways we can accommodate the 7 students, guys. All right. I'm just going to stop here before going into the combination problems, but this is again from the high school knowledge. If you have access to your high school information or the books or anything, I would highly suggest you guys to reconsider or re-evaluate those notes, especially look at the permutation sections and the combination sections. So again, memorize or refresh your memories on these 2 topics again, all right? Because you will need to know them very well to pass this course. All right, guys, I'm just going to stop here. We are in the combination, and I will upload your homework question pretty soon during today. It may not be immediately, but I will upload it today. All right, guys, thank you so much. We are 30 people. Okay, that's good enough. If there are no, if there are no questions, I will close our session for today. All right, guys, I wish you success and hopefully take care of yourself and try not to get ill and get the pandemic.